So this is section 1.4, and it is all the ways to solve quadratic equations. In either Algebra 2 or Math 102, you learned all these. So this is actually a whole chapter wrapped up into one section. All right, so let's talk first about what a quadratic equation is. So a quadratic equation is the one that has a squared in it. So this is in standard form where it starts off with something squared. So a quadratic is actually it's also called a second degree equation. So there's actually 5 ways. I've listed 4, but there's 5 ways of solving. One is by graphing, and we will talk about that later, and that's actually how you can use your calculator to either check your answers or cheat a little bit. So I'll show you how to do that later. But the other 4 methods is the zero product property, also called factoring, solving by factoring, the square root property, quadratic formula, and completing the square. So the quadratic formula and completing the square always work. Those last 2 always work. So then why do we do these first 2? Because they're shortcuts, okay? Okay, so let's first talk about solving by factoring, also called the zero product property or the zero factor property. And basically what it says is when you have 2 things that are multiplied together and they equal 0, either A, the first one has to be 0, so A, or B, or both have to be 0. So that's why we factor them, and then we set each piece equal to 0. So, right, we set it equal to 0, we factor it completely, then set each factor equal to 0 and solve those little mini equations. You'll probably remember doing that at some point in your life. So I'm just going to work a few. This is the flow chart that I made for my Algebra 1 and Algebra 2 students. So it basically shows you the steps for factoring. Notice what's always first. We try and take out the greatest common factor if you can. And then once you do that, you just count your terms. And once you count your terms, it's either a binomial, a trinomial, or has 4 terms. Might have 5 or 6, but we're not getting into that in Math 110. So if it is a binomial, you have either a difference of squares or a difference of cubes. That's essentially the same formula. It's just the sign is a little different. Or you have sum of cubes. So difference of squares or cubes or sum of cubes. Oh, let me change that a little bit. Sorry about that. I wanted to, it's not letting me. That's okay. I'll erase. So I meant to circle these guys. The sum and difference of cubes. Those are the ones that are the same. So difference of squares, or you either have squares or cubes, essentially. And then our trinomial, you either have a leading coefficient of 1 or one that is not 1. And then for 4 terms, we just use grouping. So let's just work a few of these 3. Notice the first one is not set equal to 0. So I'm going to move my 16 to the other side. And I'll get 9x squared minus 16 equals 0. And then notice that this has 2 terms. So it's either squares or cubes, and it's squares. So my difference of squares says I take the square root of that 9, and I take the square root of x squared, so that'll be an x. Then take square root of the 16, and then one's a plus and one's a minus, equals 0. And then I set each one of those equal to 0. 3x plus 4 equals 0. So I subtract 4 on both sides and get 3x is negative 4. And when I divide by 3, I have a fraction. Negative 4/3 is one of my answers. Then I do the same thing here, except this time instead of subtracting 4, I'm going to add 4 to both sides and then divide by 3. So I get x is 4/3 or x is negative 4/3. You could write that as plus or minus 4/3. So I could either enter that into my lab or 2 separate numbers into my lab. Let's do this one. Once again, I need to move my 16 over. And if you notice, I am trying to keep my squared positive. So that 2x squared, I want my squared term to be positive. So that's why I'm moving everything to the left. Anyway, so now notice that all those whole numbers, the 2, the 4, and the 16, all have a 2 in common. So I'm going to take my 2 out. So I've got x squared plus 2x minus 8. And now I have this trinomial that's right here. That's what I'm going to factor. I'm going to leave my 2. I'm going to split that up. Now let's think about 8. How do I get 8? Either 1 times 8 or 2 times 4. 3 doesn't work, 4 doesn't work. Then 4 times 2. Notice I've just flipped them, so I know that I only have 2 choices. And they have to subtract to give me 2. So I'm going to use my 2 and my 4. And then this minus sign also tells me that the signs have to be different. And I want to end up with a positive 2. So I'm going to have a positive 4 and a minus 2 because 4 minus 2 gives me 2x. So I can always just distribute that to double check. X squared plus 4x minus 2x minus 8. So that works. Equals 0. Now I'm going to set each piece equal to 0. X minus 2 is 0. X plus 4 equals 0. Now I could set this 2 equals 0, but 2 never equals 0. So I'm just going to cross that out. And then I can solve it. Now, I could solve it, or I could just say, what would I need to plug in right here to get a 0? Something minus 2 gives me 0. And that's just going to be 2. So you can add 2 to both sides if you want to, or you could just say, I know my answer's got to be 2. And over here, the same thing. I've got something, and when I subtract 4 from that something, I get 0. So that's when I add 4 to that 0, to that number, I'm going to get 0. So that's going to be a negative 4. Now, if you need to subtract 4 on both sides to get it, feel free to do that. So you could write it, I think MyLab likes for you to put a comma in between. So I think that's the way MyLab likes for you to write the answer. Let's do one more. Now notice that this one has a 10 at the beginning, and it also has a 2. Let's see, there we go. It has a 10 at the beginning, has a 2 at the end, but I don't have a number there. That's just a 1. So I cannot take a 2 out. Okay, they don't have a 2 in common. So I'm going to do, I call it slide and divide. That's what I like to use. Slide and divide. So I'm going to slide my 10 to be over there with my 2. So that's going to give me x squared plus x, and then 10 times negative 2 is minus 20. And then I'm just going to factor that as a trinomial. So I have my 2 parentheses. I know that 20 is 1 times 20 or 2 times 10. And again, these you can do in your head if you want to. 4 times 5. I think that's about all that goes in there. They need to subtract, because I've got a minus, subtract to give me 1. So that's got to be my 4 and my 5. I want a positive middle number. So I want a positive 1x. So this is going to be a positive. That's going to be a negative. So 5 minus 4 gives me 1. Now, some students forget and go ahead and write the answer here as 4 and negative 5. They just solve those two. But remember, this is called slide and divide. So I have to eventually divide. The number you slide is the number you divide. So I'm going to divide both of those, that 4 and that 5, by 10, and then I just simplify. So I get x minus, what's that, 2 goes into it 2 times and 5 times. And over here, that's what, 1/2. And really, it should be called slide and divide and slide back, because that's what we're going to do. I'm going to take the 5 and slide it back, and that and slide it back, and I would get 5x minus 2 and 2x plus 1. Now that is my factored form. And then we've got to set each one of those equal to 0. But let me show you an idea. If you factored it any other way, you're going to get what I have in brown. Okay. If you used slide and divide, I'm going to start right here. I'm not going to slide it back because I'm not really factoring it. I'm trying to solve it, right? So I could just say x minus 2/5 is 0. Well, what would x have to be? It has to be a positive 2/5. And over here, I would have x plus a half is 0. So when I move that half to the other side, I get a negative 1/2. So you could go to the brown. You could go ahead and, let's see, where did I? Yeah, you could go ahead and slide it back up and do each one of these and then set that equal to 0, and you will wind up with 2/5. Set that equal to 0, and you'll wind up with negative 1/2. But you could just stop when you have done the slide and divide, and then you wind up with two answers, 2/5 and negative 1/2. So honestly, I don't really care how you get to the factored form or to this form, okay? Whether you use slide and divide or whether you use the grouping method or turning a I call it a three-termer into a four-termer, a trinomial into four terms. Whatever your teacher taught you in Algebra 2 is fine with me as long as you can get to these two answers. All right, so that was solving by factoring, and that's all I'm going to do for factoring. So if you need help with factoring, you need to talk with Mr. Newell, go to the TLC, or come see me. All right, so now we're going to use the square root property. So the square root, again, this is a shortcut, so you don't have to use the quadratic formula. It is only for equations that is something squared equals a number. So you might have to get it to that point, get something squared all by itself. And then once you do that, you just take the square root of both sides. Okay. So we're going to work a few. So I already have, here's my quantity, something in there squared. So all I have to do is just take the square root of both sides. So that just gives me x on this side. And then the square root of 29. I can't take the square root of 29. Now notice that just has one solution right now. And up here, notice that we had two. So whenever you have a squared, you should have two solutions. And so that's why I need to put in a plus and minus, because it could be a positive square root of 29 or a negative square root of 29. So that this next one, I do the exact same thing. It's something, quantity that is squared. So I'm going to go back and I'm going to take the square root of both sides. But notice this one, I have a negative. So when I take the square root of a negative, I know I'm going to have imaginary numbers. So the square root of 144 is 12. Square root of that negative is an I. And then once again, I need a plus minus to make sure I have two answers. And then this one, I'm going to work this one a couple of times. Okay, so the first time, notice I have something squared, quantity squared. Okay, so when I take the square root of both sides, what I have left on the left-hand side is that square root and the square cancel each other out. So I'm left with what is in the parentheses, which is x minus 8, and that's the square root of 24. Let's continue. We've got to take the square root of 24. Now, 24 doesn't have it's not a perfect square. So I need to think of things that I could multiply together to get 24. So this is my thinking process. I could use 1 and 24. That doesn't help. 2 and 12, that works, but neither one of them have a square root. 3 and 8, neither one of those have a perfect square root. 4 and 6. Now 4 has a square root, so I'm going to split 24 into 4 and 6. The square root of 4 is 2, so it comes out of the house. And the square root of 6 can't do anything to it, so it stays in the house. And I have to have my plus and minus, right? Plus and minus. And then my last step is to get that letter, that x by itself. So I'm going to add 8 to both sides. So my answer is going to be positive 8 plus or minus 2 square roots of 6. And just remember 2 square roots of 6, it's just a decimal. So it's 8 plus a decimal and 8 minus a decimal, 4 point something probably, or 5 point something little. All right, so that is C. That's the answer to C. I'm going to create a D. It's going to be the exact same. X minus 8 squared equals the square, equals 24. Except I'm now, you know what? I'm going to change it up even more. Let me change it up even more. Let's do x minus 8 squared minus 1 equals, let's say, 23. And I'm going to go ahead and put a 4 in front. Let me put a 4 in front. So what I've done is I've added this, and I've added this, and I changed that by one number. Okay, so when you see something like that on a test, you just need to remember, I need to get this guy all by itself. All right, so if I had 4x minus 1 is 23, how would you get it? How would you get x by itself? You would add 1 and divide by 4, right? So that's exactly what I'm going to do. I'm going to add 1, so I get 4 times x quantity, x minus 8 squared is 24. Then I'm going to divide by 4. So I have x up here, x minus 8 squared is now 6. And now I have that thing all by itself, right? So my orange is now by itself. So I'm going to take the square root of both sides. And I wind up with x minus 8 equals plus or minus the square root of 6. Can I do anything to the square root of 6? I can't. So I'm just going to add plus 8. So I get 8 plus or minus a decimal, square root of 6. Okay, so all those are just shortcuts so that you do not have to use the quadratic formula. All right, method number 3 is completing the square. Now, completing the square, it always works, but it's not always the fastest. Okay, so why in the world would we use completing the square if we've got the quadratic formula? So the completing the square, we're going to use in this in Math 110 to solve quadratic equations. Okay, that's the purpose. But once you get into Math 111, that is not the purpose of completing the square. If all you're doing is solving for a quadratic, you don't need completing the square. But we're going to be using completing the square in 111 to make equations easier to graph, to figure out what an equation is. Do you remember problems like this? 3x plus 2y is, let's say, 8, and you had to get it ready to graph. You wanted to get it in y equals mx plus b form. Oh, that's fancy. So you would, move this over and divide by 2. You did a lot of stuff to get it to look like a line so that you would know exactly what that line looks like. Well, when you get into Math 111, you're going to do the same thing, but it's not going to be lines. It's going to be circles and ellipses and hyperbolas. So you will need completing the square. You will need to have that really under your belt well before you get into Math 111. Okay. All right. These are the steps for completing the square. Now notice there's a whole heck of a lot of steps, but the step 3 through, let's say, 6. Yeah. Step 3 through 6 is that's the main meat of it. Okay. I could walk you through each of these steps, but it's easier if I just go ahead and work one for you. Okay, so we are going to solve this using completing the square. And on your test, it's going to say using completing the square. And if you use quadratic formula, you won't get credit. You've got to use completing the square. So the first thing we've got to do is we want to get the constant on the other side. So we're going to add 20. So we're going to have x squared plus 10x. I'm going to leave a little space right there. equals 20. That space is for my completing the square. Okay, so I've got my constant to the other side, and now I'm really going to do my completing the square steps. Okay, so I'm going to look at that 10, and I'm going to take half of it. What is half of 10? It's 5, and I'm going to square it and add it to both sides. So I added it as a 5 on this side, but on this side, or excuse me, as 5 squared. On this side, 5 squared is 25. Now, a lot of math teachers won't leave it 5 squared. A lot of math teachers will literally have x squared plus 10x plus 25 equals 20 plus 25. So they will not do the 5 squared. But let me show you what I do, because once I have it x squared plus 10x plus 5 squared, that I have now done step 3, step 4, and step 5. Now I need to factor my trinomial, and I call it pull down your parts. We're going to pull down our parts. I'm going to erase this part that most math teachers do. I'm going to pull down my parts because my parts are ready to pull down right here. Okay, so I'm going to have something quantity squared, and I'm going to pull down my x, and I'm going to pull down my 5, and I'm going to pull down that sign, x plus 5 squared, which is the factored form of what I had written right there. Okay, and that's why math teachers leave it, but that's the factored form. And then on this side, I'm just going to add those. So I get 45. So I have x plus 5 quantity squared equals 45. Now, this should look familiar. It should look a lot like what we had up here, right? When we had something quantity squared equals a number. So now I'm going to use the square root method. So I'm going to take the square root of both sides, and I wind up with x plus 5 is the plus or minus the square root of 45. Well, 45 can be split into 9 times 5, and the square root of 9 is 3, and I'm going to leave my 5 in there. And the last step is to move that plus 5 to the other side by subtracting. So I'm going to get negative 5 plus or minus a decimal, 5 square roots of 5. And that would be my final answer. So let's do one more. Notice this says there is a trick. All right, so let's do one more. Here's the trick. Now I could start this by completing the square, okay? Or I could say, wait a minute, I have a 2 that can be taken out. So I'm going to factor my 2 out first. So if you can, you do. Whoops. Well, there we go. 2x plus 3 equals 0. All right. Actually, let's see. Yeah, let's do that. And then I'm going to divide it by 2. Because do you see what that does? That makes it the equation just x squared minus 2x plus 3 equals 0. So it essentially, I could have either factored it out, or I could have divided both sides by 2. Either way, I'm going to wind up with x squared. Hello, something weird happened. Sorry. Either way, I wind up with this x squared minus 2x plus 3. All right, now I'm still going to solve it using completing the square because that's what they ask. I'm going to move that 3 to the other side by subtracting. Leave you a little space. All right, and now I'm going to look at this number right here, negative 2. When I divide it by 2, I get a negative 1, negative 1 squared, right? But when I square a negative 1, that's just a positive 1, right? So I'm really just adding 1 to both sides. So now I'm going to pull down my parts. So I'm going to bring down my x. I'm going to bring down negative 1 squared, which is just a 1. And I bring down my minus sign. So that gives me what? A negative 2 on the other side. So I have x minus 1 quantity squared is negative 2. And then, once again, I'm just ready to do the square root property. So that gives me x minus 1 on the left. And on the right, I have a negative. So that's going to come out as an I, but my 2, I can't do anything with. It stays underneath the house. And then I move my 1 to the other side. So my answer is going to be 1 plus or minus I times a decimal. And once again, remember that I is just a direction in physics. So, all right. So that's how you solve using completing the square. Now, once you get into Math 111, the completing the square gets a little bit harder. So I want to work a harder completing the square problem. Let's see what makes this harder. Do you notice that there is a 4 in front and I cannot factor it out? Okay, so I can't factor that out. So what I'm going to do is I'm going to divide each piece by 4. So I wind up with x squared plus, what is that? 2 goes into that 3 times, and 2 goes into 4 2 times, plus 5/4. Oh, I should have moved that to the other side. If it's okay with y'all, let's go ahead and move that that 5/4. We need to move that to the other side. Our constant needs to go over there. So it doesn't matter if you do it at the beginning or if you do it right now. Eventually, you're going to have a constant on that side. Okay. So now I'm going to take this guy. Let me highlight him. So I'm going to take that guy, 3/2, and I'm going to half it. Now let's talk about how to half a fraction. So if I have 3/2 and I want to half it, divide it by 2. Well, that looks pretty yucky, right? So that's really 3/2, and I could write division as without that line, just a regular old division sign from elementary school. Remember, when you divide with fractions, you keep this one, you change that to a multiplication, and then you find the reciprocal. So you are multiplying by the reciprocal. So anytime you are dividing by 2, you are literally just multiplying the bottom by 2. Okay, no matter what it is. So I've got 3 halves, so I'm going to have 3/4 is what it would be squared, right? Because 2 times 2 just gives me 4. So that's what I'm going to add to this side. All right, now I am almost ready. Yeah, I'm ready to pull down my parts. So on this side, I bring down my x. I bring down my 3/4. Oh, this is supposed to be squared, isn't it? Yep. But when I'm pulling down my parts, it is I just pull down 3/4. And I bring down my plus sign. Okay, so I've completed the square on the left-hand side, but I have to continue working this fraction on the right-hand side. Now, you can work it by doing it longhand, -5/4 plus, I'm going to square this guy, so I get 9/16, and then I get common denominators, so I've got to multiply by 4. So I get -20/16 plus 9/16. That is a whole lot to get -11/16. Whew. Okay, so that was a lot, but you also can use your calculator. Let's see if I have it up here. Yeah, so I could just plug it into my calculator. So if you pull out your calculator, you could just put -5 divided by 4 plus 3 divided by 4 squared. That's probably not going to work. We're going to have to put that 3/4 in parentheses, squared. Let's go back. It's not liking me. Let's try it again. -5 divided by 4 plus, in parentheses, 3/4 squared. Why am I having an issue here? Let's try it one more time. You've probably done it a couple of times now in your calculator. 3 divided by 4 squared. Now, here we go. So they gave us a decimal. In your new calculator, the way you go from a decimal to a fraction is you go under math. So you're going to plug this in and then go to math. And once you hit math, one of the very first thing says change it to a fraction. It does that. Change it to a fraction. So you then just hit enter and hit enter again because it says make that answer a fraction, and it is now negative 11/16. So if you just want to use your calculator to do that instead of all of this, feel free, okay? I don't have to see how you get that negative 11/16. All right, now we got to take the square root of both sides because it is, we can use that square root property. So I have x plus 3/4 equals, all right, so we've got an issue over here. I cannot take the square root of 11. So that has to stay under the house. But that negative is going to come out as an I. And then the bottom is the square root of 16. That's just a 4. And then don't forget the plus minus because we need to have two answers. And my last step is to just move that negative 3/4 over by subtracting. So I get x is negative 3/4 plus or minus I square roots of 11 over 4. Whew. You will be doing things like that a lot in Math 111, okay? You won't go all the way to the answer. You're just going to go to, in Math 111, you're just going to go to this part where you have completed the square. All right. Last but not least is the quadratic formula. Okay, so our quadratic formula, you have to know that equation. Okay, you've got to know that formula. If you don't know it, should I sing it? On this video? I don't know if I should sing it on the video. You can just go into your notes and click this YouTube video, and you will see what I'm getting ready to sing in like 3 or 4 part harmony. It's really cool, and it gets stuck in your head. But all right, so it's x equals negative b plus or minus square root b squared minus 4ac all over 2a. So you want to get that stuck in your brain, especially if you haven't memorized that. All right, so we're going to be using the quadratic formula. You may remember that the quadratic formula is only works if your quadratic equation is set equal to 0. So that's the very first thing we need to do to this example is set it equal to 0. So I'm going to move that 3 to the other side. So your a value is whatever is in front of your x squared, which in this case is going to be a 1. Your b value is whatever's in front of your x, and your c value is your constant. And now we're going to plug those values, and sometimes it helps if you actually write it out. A is 1, b is 6, c is negative 3. That, for some folks, that really helps. And now we're going to plug it into my formula. I'm going to write my formula out. X equals negative b plus or minus square root b squared minus 4ac all over 2a. I write it out, and if you write it out over and over and over again, every time there is a problem with the quadratic formula, you will get it in your noggin. All right, so negative b, and my b was a 6, plus or minus b squared minus 4ac. My a was 1, my c is negative 3, and all over 2a. And again, my a was 1. That's supposed to be negative 3 right there. Okay, so let me talk about one of the traps. Okay, so we're going to have x equals negative 6 plus or minus. One of the traps is 6 squared is 36 is going to be this sign right here. Is one of the main things that students miss. Okay, what I normally do is I just go ahead and take these numbers, the 4, the 1, and the 3, and I ignore all signs and I just multiply them together. 4 times 1 times 3, that's going to give me 12. So I go ahead and put my 12 here. And then I go back through and I count my signs. I have my negatives. I've got one negative there and I've got a negative there. And I know this is really a subtraction, but you could think of it as plus a -4. So I've got two negatives. Two negatives give me a positive. So a lot of students miss that sign. So that's the very first trap that we normally have, is that sign. I'm going to show you some other traps in a minute. All right, so let's keep on going. So that's going to give me -6 plus or minus the square root of 36 and 12 is 48 all over 2. Now 49 has a square root, but 48 doesn't. So I start thinking of what goes into 48. I noticed 4 goes in there. So 4 goes in there, let's see, 12 times. So that would work because 4 has a square root, but do you notice that the 12 also has a 4 in it? So you could think of that as 4 times 3. So now I have underneath this radical 4 times 4 times 3. Or you could have thought of it as 16 times 3. But when I look at 48, I don't naturally think 16 times 3. But anyway, so now I've got those two 4s will come out as that 1 4. They're single. They're going to be married. And then I have the square root of 3. So let's see. Let me put it all together. I did not put it all together. So let's do -6 plus or minus 4 square roots of 3 all over 2. Now, notice that this 2 does not divide into this 3. But that's okay because I couldn't divide it anyway. It's got a square root. But 2 goes into 4 and 2 goes into the 6. So you can either do this on paper or you can do it in your mind. -6 over 2 plus or minus 4 square roots of 3 over 2. But if you could do it in your head if you wanted to, and just divide -6 by 2 and get -3, and 4 by 2 and get 2. All right. Let's do one more. Once again, it's a quadratic formula. It has to be set equal to 0. It doesn't really matter whether I move this 4x squared on the right or if I move all of these guys on the left. I tend to still like keeping my x squared positive. So I'm actually going to move that 3x and the -5 to the other side by subtracting 3x. So I'll get -3x on that side and adding 5. So I get +5. So I now have 4x squared minus 3x plus 5. So now let's figure out what my letters are. There's my A is -4, A is 4, B is -3, C is a +5. If it helps you, you can write it out to the side. You do not have to do that, but if it's helpful, please do. Then I'm going to write my formula down. X equals -b plus or minus square root b squared minus 4ac all over 2a. Once you get used to that formula, you do not have to write it down every time. Anyway, this one has lots of traps. Okay, and the reason it has lots of traps is the b value is negative. Whenever the b value is negative, you've got 2 more traps. Okay, so the first one is, notice I have -b as my first part of my formula. So -b, and my b is negative. Do you see how those 2 negatives would make a positive? A lot of students just leave off that negative of the b. Okay, then on the inside, underneath my square root, I've got -3 squared, because that's my b squared, minus 4ac. So my a is, let's see, oops, supposed to be blue. Okay, my a we said was 4, and my c is 5, and then all over 2a, my a is 4 again. All right, so let's keep on simplifying. So again, the very first trap is this double negative. So The fact that it is a positive 3 is your first trap. The next trap is this negative 3 squared. Negative 3 times negative 3 is a positive 9. So you will always, that first number will always be positive. And I have students that say negative 3 squared is negative 9. So that's always positive. And then we've got our 4 times 4 times 5. So I'm going to do 4 times 5 is 20 times 4 gives me 80. I think that's easier to do in my head than 16 times 5. And then I only had one negative. So that was one of my traps. Remember, that was my older trap. Other trap was that sign, but it's not really a trap in this one. And then I'm going to divide it by 8. So I get 3 plus or minus the square root of negative 71 over 8. I can't do anything to that negative 71, but I can take that I out. So that's my final answer. 3 plus or minus the square root, 3 plus or minus I, square roots of 71 over 8. Now, in my lab, they ask often for it to be written in A plus BI form. If not, you can put this answer down, and that's what you can put on my, on my test. But if they ask for it in A plus BI form, remember that means you've got to separate it. There's my first part, 3 over 8 plus I square roots of 71 over 8. That's the MyLab answer. Okay, and if you put it in not in A plus BI form, they will count it wrong. Sometimes they tell you why, sometimes they don't. So, all right, let's talk a little bit about the discriminant. Now, the discriminant, math people get so excited about the discriminant because they realize that if you have, let's just do one. If I let the discriminant is these numbers that are the number that you get underneath the radical, underneath the square root. So let's say that it was a 0. Let's say that I had, let's do this last one that we had, 3 plus or minus the square root. Let's say it's 0 over 8. Well, notice that that's going to give me 3 plus or minus 0. Well, what's 3 plus 0? 3. What's 3 minus 0? 3. So you're always going to get this positive 3. So I've got one answer. Okay, so when it's a 0, you have one solution, and the type of solution is it's a real solution. There's no imaginary numbers. They call it rational. Rational just means it's a fraction. That doesn't mean it has to be a fraction. I could have gotten an answer of like 2. But they call it rational because you could write it as a fraction. What if it is negative? What if the number underneath is negative? Well, we did one that was negative, right? This one is our negative one. Whoops, sorry. So there's our negative one, right? We've got the square root of negative 71. Notice what we had. We still had 2 answers, but we had an I in them, so they're imaginary. Okay, so if you have a negative underneath, it's an imaginary answer. What if it is not a perfect square? So we had one up here that was not a perfect square. Notice that we got 48 underneath. So when it was 48, notice I still have 2 answers. And they're real numbers. I don't have any imaginary, okay? But they are irrational. They've got a square root of 3 in it, okay? So if it's not a perfect square, I'm still going to have 2. They're going to be real, not imaginary, but they're going to be irrational, which means it's got a square root in it. That's what irrational means. It's got a square root. Now, what if it has a perfect square? We haven't done one that has a perfect square, so let's just look at one. I'll just make it up. 4 plus the square root of, let's say, 9 over 7. Or let's say 8 over 8. Okay, so, oh, this is plus or minus. So that's going to be 4 plus or minus 3 over 8. So my answer could be, if it was a plus, it would be 4 plus 3, so that would be 7/8. If it was a minus, it would be 4 minus 3, so that would be 1/8. So notice I still get two answers. They are real, but they are going to be rational. They're not going to have any square root in them. Okay. So in my lab, and I might even put one on the test, I haven't decided, but they may say, find the discriminant and tell how many solutions and what type of solution. That means they don't care if you go all the way to the answer. In other words, for example, number 6, I would, the only part I would do is this part right here, and I would find out that my discriminant is -71. I would immediately say I have two answers and they are imaginary. Okay, so that's the kind of questions they may ask in my lab. So I'll work one more. So let's see, letter A. I know that this is my A, this is my B, this is my C, and I need to find B squared minus 4AC. So my B squared, notice that my B is a negative, right? It's a -12. So you have to be careful with that. -12 squared minus 4AC. So that gives me what? 144 minus 4 times 4 is 16. 16 times 9 is, oh, that's 144 too. So 144 minus 144 is 0. So that means if I had one where I took the 0, where the square root, underneath the square root was 0, remember what that means? That means I'm only going to have one answer. One, and it's a real answer. I'm not actually going to work the B, the C, the D, but I am going to give you the answers. B, you should get -59. Don't forget to move that -5 to the other side. So you should get -59. So that's you're going to have two answers. The only time you have one is when it's 0. So you're going to have 2, and when you take the square root of that, that's going to give you imaginary numbers. So 2 imaginary. This one, you've got to move the 6x and the 7 to the other side. When you do B squared minus 4AC, you'll get 92. 92. So you're going to have two numbers. And when you take the square root of 92, notice the square root of 92 doesn't have it's not a perfect square. So that means it's going to be real, but they're going to be rational numbers. It's going to be, irrational. Irrational numbers. They're real, but it's going to have a square root in it. And then this last one, I move the -1 over. Once you do B squared minus 4AC, you get 9. The square root of 9 is just 3. So you're still going to get 2, but you're going to have rational numbers. In other words, you're not going to have, there's no square roots in them. All right. If you are still confused about either solving by factoring, solving by completing the square, even solving by completing the square where it's one of those harder problems, or solving using the quadratic formula, if you go into your notes in D2L and just click those links, you can go to some more videos that show someone else teaching you how to do those. Also, Quad Solve Rap. If you like rap, click on that video, and it's just fun. That's all I got to say. It's just a fun video. It basically tells you when to use these things. All right. The last one that we're going to talk about is factoring when we have something to the third power. We've only done things to the second power. So we're going to do to the third power, but they're special. These are special in this section. We're not really going to get to x to the thirds or things to the third till the third, next chapter 2. But anyway, but factoring until we get to chapter 3. But this one, when they're special, you can do it. So these are called difference or sum of cubes. So we're just going to factor it. And this is a fancy formula. Honestly, I'm not a good memorizer. If you're a good memorizer, memorize that formula. But I'm just going to show you the pattern. Okay, so here's my pattern. I am going to take the cube root of each one of these. Okay, so the cube root of the first one, notice the cube and the cube root undo each other. So that's just going to be an x. The cube root of 125, if you don't know how to do that, you can do it on your calculator. Under math, you go down to the fourth one down. See, it says cube root 125. That'll give you 5. Okay, so the cube root of that is 5. So that is the very first part. Okay, and I brought the subtraction down. So we're doing this one. So I just did this part. Okay, now I like to just look at the pattern. I'm going to say, take that first one, multiply it by itself. X times x gives me x squared. I'm going to do the same thing for the last one. 5 times 5, that gives me 25. It's always positive. Even though that was a -5, -5 times -5 is positive 25. Then for the very middle term, because we're going to have a middle term, you're going to take these two and put them together. 5 times x. And the very last thing that we need is the sign of that 5x. Let's see, I'll do it in pink. So if we started off with a negative, then this is going to be a plus. Okay, so when we factor that, we wound up with x minus 5, x squared plus 5x plus 25 equals 0. So we factored. Now, can we keep factoring? Can I break this? Anytime you have a squared, you want to see if you can keep going. 25, I've got 1 times 25 and 5 times 5. That's how you get 25. Did they add to give me 5? They don't. So I can't actually factor that one. So in your last class, you probably just left it, but we're going to keep going, okay? Because we have the quadratic formula. Now, you could use completing the squared, but we're just going to use quadratic formula. I don't need it for this part, right? X minus 5. So if I say x minus 5 equals 0, what's going to make that 0? A positive 5. So that's one of my answers, okay? All right, let's do another one. Let's do this guy. I'm going to use my quadratic formula, -b plus or minus square root b squared minus 4ac all over 2a. So my a is 1, my b is 5, and my c is 25. Let's plug it in. -5 plus or minus 5 squared minus 4 times 1 times 25 all over 2 times 1. And I just keep trucking. I call this plugging and chugging. So that's going to be 25 minus 100. Whew, all over 2. Let's keep on going. So minus 5 plus or minus square root of -75. So we now know, because it's a negative, that this is going to be imaginary. That's okay. We'll keep going. Now, 25, I'm going to break up, 75, I'm going to break up into 25 times 3. And 25 has a square root, so it's going to come out as a 5. The negative comes out as an I, and the 3 has to stay in the house, right? Because I can't take the square root of 3. All over 2. And because 2 does not go into 5, I'm done. If this was a 6, then I would have to keep simplifying, even though 2 didn't go into the 3. But that is that answer. So my final answer is 5, and then -5 plus or minus 5i square roots of 3 over 2. Notice I have 3 answers. Well, that makes sense because I started with the x to the third. All right, last thing. The last thing is just solving for a variable. Okay, you've done this a lot in your algebra classes. It's just this one has some squareds and some cubes and that kind of stuff in it. So I would just want to make sure you know how to work this one. I'm solving it for r. So my r, notice that my r has a squared on it. Okay, but I need to get it all by itself. Well, first thing I notice is I've got a fraction. I want to get rid of my fraction. I don't know if you remember how to get rid of fractions the easy way. I am going to, we talk about flipping and multiplying. So I could write that as 3 over 1. You don't even have to put the over 1, do we? So if I just multiply by 3, do you see how those 3's cancel? So whatever I do on the right-hand side, I've got to do on the left. So I'm going to multiply by 3 or 3 over 1. So I'm going to have 3v is equal to pi r squared h. All right. Now, I still need to get this guy by itself, r squared. Notice that these guys are just multiplied, right? These are multiplied. The way you undo multiplication, remember, is division. So I'm just going to divide by pi h. So I get 3v over pi h is equal to my radius squared. They didn't ask for radius squared, right? They asked for the radius. How do I get rid of the square? Remember, you just take the square root of both sides. So now I know that my r is equal to, oops, let's do it in blue. My r is equal to plus or minus 3v, the square root of 3v over pi h. I would love to say that that is your answer. The problem is somebody somewhere said you cannot have a square root on the bottom of a fraction. I don't know who. If I could go back in time, I would try and change his mind, but that's what he said. So you might say, but there's not a square root. If you split it up, you see that there is a square root. Okay, so we're going to rationalize our denominator. You do that by, in this case, I'm just going to multiply by the denominator again, the square root of pi h, square root of pi h. So what's that going to leave on the bottom? It's just going to leave pi and an h. Right? On the top, I'm going to have a 3, a v, a pi, and an h, and a square root over them. So that's my final answer. Be very careful when you're putting this on your answer sheet for your test or in MyLab that it is very noticeable that that square root is just on the top and doesn't go to the bottom as well. So that is your final answer. All right. The very last problem is, I'm just going to tell you, it is weird and it is tricky. Weird and tricky. Okay. Which is a MyLab favorite. They love weird and tricky. All right. Notice that this has something squared. So they want us to solve for y, and that y is squared. All right. So I can't factor this thing. There's no way I can factor it. So I could use completing the square, which I would not suggest, or I can use a quadratic formula. So we're going to use the quadratic formula on this weird thing. For quadratic formula, it has to be equal to 0. So I'm going to move my 3p over. So 2my squared minus ny minus my 3p on both sides. So minus 3p equals 0. Now notice that I have a y squared and a y and then something else. Okay, so it looks like it's in standard form. It goes from y squared to a y to usually a constant, but this has a letter. I'm going to highlight all of my a's and b's and c's. So 2m is my a, minus n is my b, and minus 3p is my c. So basically, this problem is to see if you can apply the quadratic formula even when it's not making a bit of sense. Okay, so I'm going to write down the formula. Do you want me to sing it for you? X equals negative b plus or minus square root b squared minus 4ac all over 2a. Now I'm going to plug in my numbers. Let's see, b is negative n plus or minus, you just have to be really careful when you're doing this, negative n squared minus 4ac, and my a was 2m, and my c is minus, whoops, I almost forgot my minus 3p, all over 2a, and my a is 2m. And now we're just going to try and simplify, okay? So let's simplify. I've got x equals, my two negatives give me a positive n, negative n squared. Okay, so that negative n squared is just going to be n squared. The two negatives will turn into a positive. Okay, now let's just look at my regular old numbers here. Look at the 4, the 2, and the 3. Don't worry about the signs, but 4, 2, and 3. So 4 times 2 is 8, times 3 is 24. So I'm going to put 24 there. Now I'm going to write down any letters that I had. So now I have an M and a P. So I write down my M and my P. Whew. And then I've got two negatives, or a subtraction and a negative. But let's say two negatives. Two negatives give you a positive all over 4M. Now my question is, are we finished? Am I finished? Well, notice the only thing I could do is like divide some things, divide this by this. Well, I can't do that. For one, I got super glue, okay? But I've divided when I had super glue before, but they had to have the same thing here and here that was canceling out. I don't have that. Some folks like to try and take the square root of that square, but you can't, because that plus says it's super glued together. So I can't do anything to that guy, to the square root. So that is my final answer, and it is yucky, right? But again, this is trying to get you to start doing these steps, even when it doesn't make a lot of sense. You just keep working those steps until you get to an answer. All right, we are done with section 1.4. So now try to do the practice and then demonstrate.